Hello everybody! Today is another instance of AIOps Explained. We are still in the IBM Cloud Pak for AIOps version 4.5 release news mini-series, and today we are going to concentrate in a deep dive on log anomaly detection and golden signals, and in there we're also going to talk about training with historical data as well as how to customize templates. And for that specific topics we have help, of course. We have Amy, she was already part of another video, and we have also Pujitha Kara and Meenakshi Madugala. I hope I pronounce it somehow understandable. That's not my native language, so please don't hang me on that. All those are part of IBM Research and Development and Software Engineering. And my name is Fred Klein, and I wish you fun. But before we are going to hand over to these software engineers, we are going to highlight what is part of this series. So all these topics are part of this mini series. So quite a number of videos we're going to have in this release update, because there's so much happening in this kind of environment. And here's the topic of today: log anomaly detection, golden signals, as we already highlighted. But before we are going to hand over to Amy, this is the link to the documentation. So we are currently in the release number 451. And the documentation has been updated on the 7th of May lastly. And here's a starting point how to read into golden signals in log anomaly detection and all these kind of things. So have fun.
Meenakshi,
take it away, please.
I'll be walking through the changes to the log anomaly golden signal specifically that we made for 4.5. Just a high-level overview, we changed three things. We added three things. One is the historical data training that allows you to train the metric anomaly as well as the templates by using historical data. We have some enhanced template editing options. A user could add a custom template pattern or as well as delete templates. And on the alert viewer, we also made some improvements to show logs from log aggregator and also some changes to the graph. We can look at all these three things in depth in the demos. So firstly, for the historical data training, the time to value has reduced significantly. Earlier, we used to use the live data for initial AI training, which made the training take at least 3.5 days. But with historical training, now we just have to wait for a few hours to train both the templates as well as the metric anomaly models. One catch here is since we need the data in time sorted order, we must make sure that the source parallelism is set to 1 always, but it still should be faster than the live connection. Let's quickly take a look at the demo for that. So for now, I don't have any trained templates, and in my AIOps, I just have one connection and it should be disabled for now. I can quickly turn that up. So here I'm using a historical data for initial AI training option. I've selected an older start and an end date with a source parallelism of 1. Once I save this, there should be data coming in fairly quickly. And once it starts running, once there are about the initial 100K log lines collected, we should be able to see some templates. One advantage of using the historical data is, say, after training the first initial set of models, if there are new resources introduced to the system, we could use the historical connection then to train the newer resources. So it's very advantageous rather than using the live connection and you need to wait for a couple of days before you see the results. Going back to the AI model management page, it probably would take about 1 or 2 minutes to show up here, just because it needs to collect the initial set of data and then train them. one other slight difference as well, since we definitely require the time sorted order, you cannot use historical training for resources that have already been trained on a future date. We could either use it for initial training and later on for the case where if new resources are added, that's the case we could use it as well. Yeah, I guess the next run is at 14:13, so just a minute more before we see those results, and then we can move on to the next topic. This might take a bit while because it's saying it has less logs than the 100K, but we can come back to this later and look at the others. I'll pass it on to Pujitha to quickly walk over the enhancing templates.
Sure. Thank you, Meenakshi. Hey everyone, this is Pujitha. I'm just going to cover the topic template editing that we added as part of 4.5. So this topic majorly covers the customization of the templates itself, like allowing the user to add a custom template or to delete any existing template. So the major use case is like imagine we do have some input data from the user and extracted initial set of templates. But if the SRE feels that the set of templates do not cover any important pattern that they feel is causing any incident or later is like some root cause analysis related log, then I think we allow the user to add a template pattern which is made available in 4.5. So for adding the pattern itself, we just expect them to enter like a sample log message, like I said, which could be the root cause analysis one or anything that is very important to the SREs, which was not already extracted or auto-generated from our model itself. And based on that log, we try to generate like an initial version of the pattern, and the user is allowed to change any fields, individual tokens in that particular template itself. Like if they want to convert static to any one of these predefined types like URL, IP address, and vice versa. And as with any other editing of the templates, we also allow them to edit the golden signal associated, like based on the initial log pattern that they gave here. We do assign a default golden signal, but at the same time, if the SRE feels that should belong to a different golden signal category, they're allowed to change that as well. And state enable disable as well to determine if we want to take that particular metric related data to metric anomaly detection, or do we want to just discard kind of any information related to that template. So basically, this is the overview of the editing of the template, and similarly, they are allowed to do like a deletion of the template as well. Like a use case there, I would imagine is like, say, if they don't think the quality of a particular template is good, or they don't want a particular template to be present there, they are allowed to delete the templates. Let me quickly show a demo. So this is, I think we just have a summary of pre-trained templates here. So I just have about 292 total templates here. We did add like a new column here just to show which particular template is auto-generated one and which one is custom added. So this particular button takes you to the add template UI itself. I'm just giving a random message here with some URL. This is the initial version. This template is generated based on some predefined knowledge we have, like based on all those individual count pairs and pair count maps that we have seen in the template corpus so far. Based on that, we try to generate all of these individual tokens here, and which has to be like a variable, which has to be a static and all. Like I said, they are allowed to do editing on top of this. They could convert any of these AQL types, like basically entity types, into any one of these predefined ones like IP address, date, time, or anything. And similarly, they can convert the static tokens as well into one of these variables if they feel the template generation that we have done hasn't identified a variable as a variable. Similarly, they can just choose any of these predefined ones, or they just can choose to keep it as a static one. So once the user has done editing this, you can just click on this, and golden signal type, you are free to modify any of these values. Let's just say it's traffic here. I'm the enable state, I'm just keeping as is, and create a template. So once the template is created, as you can see, there are two new additional states here, enable pending and disable pending. So basically what that means is we just take one training cycle to make this template as an actual available template. This is for our technical reasons to make sure that you're not clashing the template IDs created from your custom to with the actual training. So that's why we show that under enable pending. When it is in the enable pending state, the user is again allowed to go here, edit the template or do whatever they want, similar to how they edit the rest of the templates. But in addition to allowing them to change golden signal and state, for these custom templates, we do allow editing the pattern as well. And this can be done either when the template is in that temporary state before it's converted to actual template, or even afterwards, like when the training cycle is kicked in and it is converted to actual template. Even at that state, they are free to change either the pattern, golden signal, or the enable state itself. So in general, for normal templates, we allow only changing golden signal and the state itself. So that's with add template itself. And let me just quickly show you the delete as well. Like I said, like say if the user thinks a particular template is not of good quality, or they just don't want this template to be present because it does actually capture some error logs or whatever the scenario is, we do allow at this moment deletion of template on an individual basis, not like a bulk request. Each template by template, they are allowed to delete the template itself. So as you can see, once it's deleted, it just shows here, and all the counts associated with like the total number of templates enabled, disabled are updated accordingly. So yeah, mostly those are the two use cases we added in terms of add and delete. Basically, this is to provide more power to the SRE to take a control on the quality of the templates itself. That's it from me. I'll pass it on to Amy.
Yeah, thanks, Pujitha. So, hey everyone, I'm Amy, and I'm going to be doing a quick demo for the enhancements that we added to the Alert Viewer UI. So just like as a summary, we were focusing on adding features that would allow users to have more control in visualizing the data and understanding the alert within its context. And in this cluster, I already have some raised alerts that were generated through running the golden signals process, where I got some templates trained from the incoming log data, and then I injected some anomalies to generate this alert. Here on screen, I have the alerts page for my cluster. A user can click into the alert, which will open up a side panel that shows some brief overview of information about the alert. To get more information, I can click into this link at the bottom that says View Expanded Chart and Log Messages. This will open up a full details page, which is where I'm going to show you the enhancements that we added for the 4.5 release. To start off, the first enhancement that we've added to this release is this date time filter panel, which is going to be visible on both the graph view and the logs view. By default, the full details page opens on the graph view, which is what we see here, and we can use this context switcher on the side to toggle between the graph view and the logs view. If I click into the logs view, we can see that the same filter panel appears at the top. This is meant to help provide some consistency in the interaction between the graph view and the logs view. Now let's go back to the graph view and take a look at the first date filter we have here. The label says graph start date and graph end date, and this corresponds to the graph that we see below on the graph view. Previously, this graph only had a single date selector that would allow users to view a particular point on the graph, and the graph would automatically show 7 days surrounding that one point. In this release, we're providing a date range filter where the user can specify a start date and an end date so they can have more control in manipulating the window shown on the graph. For example, let's choose a different start date, such as April 6th. We can see how the graph automatically shifts to match the start time. Similarly, we can choose a different end date, say April 9, and the graph will adjust itself to match that as well. Let's go back to April 7th so we have a better view of our data. We can see how this date filter with the start date and the end date allows the user to have more control in zooming in and out of a date range because they can specify the exact dates of the window that they want to view. Now let's move on to the second date filter, which is titled Logs Pinned Start Date and Logs Pinned Start Time. Previously, this filter corresponded only to the logs table on the logs view and allowed users to choose the starting point of the logs to be shown in the table. A new feature that we've added to this release is that the timestamp selected for the logs view using this filter can also be visualized as a pinpoint on the graph view. If we hover over the pin on the graph, we can see a label that shows the exact date and timestamp that is being marked. So here we can see it says that the pin time is April 6th at 6:25 p.m., which is what we see in the filter as well. From the graph view, we can modify the date and time of the pin by using the logs pin filter. So let's say we change it from 6:25 to 4:25 p.m. We can hover over the pin to verify that it's now at 4:25 p.m. And if we want to hide the pin from the graph, then we can click in this icon here that says Unpin Logs Start Time, and the pin will remove itself. We can add the pin back into the graph by clicking in the pin icon again. Like previously mentioned, this filter is also used for the logs table. We can go back to the logs view using the context switcher, where we can see that the logs table is populated with logs that begin from the timestamp selected, which is 4:25 p.m. If I make a change once again to the time, say from 4:25 to 4:35, then we can see the logs table will adjust such that the logs in the table now start at 4:35 p.m. If I go back to the graph view, I can see that the pin time now says 4:35 p.m. instead of 4:25. This change is meant to help connect the gap between the graph view and the logs view, so that rather than them being two separate entities, we can help the user to see how the selected log messages can be visualized within the context of the graph. For this particular example, the pink section in the graph denotes an anomaly was detected due to what looks like some flatlining of data. We can verify this by using the filter to move the pin back to the pink section, say 5:35 p.m., which we can see the pin moves itself here. And now if we go to look at the logs table, we can see that this flatlining anomaly was raised because there were no logs found for this timestamp. So this new enhancement ties together both the graph view and the logs view and helps users to use them hand in hand to both visualize the data in the graph and also to see the details of the logs in the table. The last enhancement that we've added to this release is the button to launch the logs aggregator. This button will be accessible from the logs table as this blue button that says Launch Log Aggregator. If we click into this button, it will open up a new tab that corresponds to the log aggregator for this alert. The link will open directly to the selected timestamp that we had chosen for the logs table in the alert viewer. This allows users to see the alert's logs within the context of the streaming logs and therefore better understand the scenario that the alert occurred. So in summary, with our new enhancements to add the date range filter, pin tool, and button to launch the logs aggregator, our changes in this release aim to provide the user with more tools to visualize and understand the logs of the alert. Thanks for watching. Yeah, so that's my demo. I'm going to hand it back to Meenakshi if there was anything else that you wanted to show.
Thank you, Amy. Yeah, just quickly check that the training is ready. So we have the train templates and we can just look at those. Yeah, these are the templates that were trained on historical data. So that's the reason why you don't see any log messages in the last 24 hours. They are all empty. That's all I wanted to show. Thank you.
Thank you all three. That was very insightful. Thank you for preparing all this material that you just presented. Thank you the audience for spending again time with us in this video, and I'd like to thank you for being part of this. And with that, I'd like to close this video for today. Watch it again when it is AIOps Explained. Bye.